So to design our model, I'll go to design, then concrete frame design, and I'll click start design or check. Also from that option, concrete frame design, just click here and click start design or check. So I'll click here and it will start designing our model. So our model have been designed perfectly. Here we're seeing our model have been designed. Now we're seeing this value in millimeter. Okay, so if you need to change that value, just click here and from here select any of that unit. I'll click here US matrix and see here everything have been changed. Okay, now first of all I'll go for our column. So I'll go elevation, and from AA, I mean for that sequence, here you will get A6, A4, A2 and A1. So here serially. Now we have to check our value from here. So you're seeing that for that column we record 4.7 inch reinforcement. For that column we need 3.19 inch reinforcement, and here 2.7, and here 5.8 inch reinforcement. If I right click here, and you can see that for which combination you need this reinforcement. So if you go for interaction diagram, and you will see what is the value of your demand capacity ratio. So here we are seeing our demand capacity ratio is 0.941. That means this is almost okay. Okay, this is almost okay, but it will be better if we increase our column size. Now I'll just click cancel and I'll click close, and after that I'll go in the section BB. So here for that one we record 5.6 inch reinforcement, and here we're seeing that we record 8.45 inch reinforcement, and here 10.16 inch reinforcement, also here 3.99 on 7. Okay, and again I'll go for next one E, and here also we need 8.1793 inches square reinforcement. Again here 6, then 9.7 and 3 point something, and for D we're getting more reinforcement in our bottom. So what will do, actually I will close it, and again I'll go here, and for display design info I'll check the reinforcement percentage. I'll click here, then I'll click apply. So I'm seeing that here 2.87% reinforcement required. So this is very natural and normal. And if you need to optimize that, just listen me carefully. If you need to optimize this required reinforcement, then you have to increase your column size. So if you increase column size, then required reinforcement area will also decrease. Again, if I go for elevation view C, here 3.7 inch reinforcement required here for that column. And if I go for interaction diagram, with our interaction diagram, this is almost okay. Okay, it's okay, 0.993. So it will be better if we increase this column size little bit. So here 15 into 18 inch column size we have used. So if you use this column size as a 15 into 20 inch or something, that required reinforcement will decrease maybe. I'll close it, and again if I just go here, so for C, now here also you're saying that 2.87%, this okay. here 2.31% reinforcement, and here 3.30% reinforcement. So as per ACI code, we know that our required reinforcement ratio is 1 to 8%, and it's better if we use less than 40% reinforcement. It will be economical, also it will be more working friendly. So you have to think on it when you are going to construct this structure or when you are going to design this structure. So for column, we're seeing that almost for every column our required reinforcement and size is okay, but if you need to increase some column size, you can do that, no problem. So I'll close it. And by taking reinforcement from here, how we'll detail, or how we'll go for detailing and how we'll find out the number of reinforcement, we'll take it. But before that, I'll click here and we'll go for verify all member passed. So if we see 16 concrete fails to design check, so I'll go yes to select all of our member which have been failed, and from here I'll right click and show selected object only. Just see, here's some beams, here's some beams for that, and for that beam they are failing actually. Okay, and if I right click, they're failing for overstress 45. So I'll discuss on some failing mode, okay, and at which situation what you have to do.